don't need to understand all the math details. All you have to understand is the central idea. Read the introduction, read the conclusion, and then without worrying about whether or not the math is correct, or whether or not you understand exactly what an affine transformation is, read the body of the paper and see if you can get a sense of what was going on. He came back a month later, and without understanding the math, he understood what the authors were trying to communicate. And he could give a very simple, straightforward explanation of the premise, the working premise of the paper. So that's how you read an academic paper between now and 2 weeks from now when you put in your annotated bibliography, and communicate to me that you got something out of it, and you understand why that paper is relevant to what you were working on. Okay. In your textbooks, you read the chapters in the textbooks the same way. You read the introduction, you read the conclusion, you go back and read the body of the chapter, and then usually at the end there are, I think Zoom does it too, at the end of the chapter, and have some bullet points. You cover conceptually great ideas that came up in the chapter. And you look at those and you sort of fool yourself. Okay. So you're going to need to do a title, an abstract, and then a annotated bibliography, and an outline. And I'll put an example of an outline in there. An outline is not a first draft of the paper. An outline tells you the section heading for that section of the paper, and then it tells, in like bullets, the main points that are going to be dealt with in that section of the paper. It's not a draft of the paper. You don't have to write sentences and paragraphs. It's just a statement of the ideas that are going to appear in that part of the paper, so that I know that you have thought about how you're going to organize the paper. Let's Dave Baduri. Dave, why did I have you do that homework last week? Apart from the fact that I wasn't here, that I wanted you to have a meaningful educational exercise, why did I have you do that? Okay. Is it an important distinction? What's the difference between partial correlation and regression analysis as it's understood in, are you in the condensed fund? What's the difference between partial correlation as it's understood by people who wrote the entry in Wikipedia and regression analysis as it's used in finance?
Well, in order to come up with a proper regression, you identify what all of the relevant variables, and partial correlation I guess leads to poor conclusions for regression if you use variables and ignoring an outside variable instead of the data that you're looking at. I'm not sure I'm explaining it properly.
Anybody else want to take a stab at distinguishing between partial correlation and regression analysis? Dave correctly told us that there's an important distinction between causation and correlation, and that I think everybody, I flipped through some of the things that people wrote, and everybody pretty much understood that if X causes Y, that there's going to be some correlation between them, but the correlation between them doesn't imply causation. Everybody had a pretty good grasp of that idea. But now I want to go a little bit further and distinguish between partial correlation, which everybody understood that if there are 3 variables X, Y, and Z, and you remove from the variation in Z that part which is explained by Y, and then look at the correlation between x and that residual, that's partial correlation. But what's the connection between that and regression analysis as it's used in economics and finance and so on?
Well, if you're writing an empirical paper, you want to have a bunch of control variables in it to show that, or not too many variables, I guess, but you want to have some control variables in it so that you're well, basically controlling for the influence of factors other than what you're trying to show a relationship between. If you're trying to show a relationship between x1 and y, you don't want to have x2 through x100 also influencing y.
You're so close. Suppose that I told you that the mean weight of Temple students was 140 pounds. And then I told you that the mean weight of male students at Temple is 170 pounds, and the mean weight of female students at Temple is 120. What would be the difference in the way that you interpret the first one and the second two? Conditional on gender, the mean weight is different. Correlation and partial correlation came up as ideas in statistics as a consequence of the way people in the social sciences thought about things. Sociologists, psychologists, anthropologists, so on and so forth, regularly look at the joint distributions of random variables. Typically, their statistical modeling of those joint distributions is theoretical. They could care less about having a coherent and consistent, generally applicable theoretical model of behavior. But they're very much interested in joint distributions. And so partial correlation is a discussion of the joint distribution between x and z after you've integrated out y. When people in finance and economics and I suppose accounting and some other things like that did a regression model, what they're interested in is the conditional mean of y. The mean of y conditional on this set of right-hand side variables, which is a slightly different interpretation of the world than the way in which people in psychology and sociology interpret the relationship between x and y. It's a difference between a joint distribution and a conditional distribution. So that was not a question that I pursued last week, but it's an important distinction. And so you have to be clear in your own mind, in your own discipline, whether or not your interest is in the joint distributions, or whether or not you're interested in conditional distributions. Economics is commonly interested in conditional distributions because we have a strong notion about how the world works. And we often say, if price increases, all other things equal, the quantity demanded is going to fall. So we're always immediately putting ourselves in the realm of conditional distributions. Whereas somebody in psychology, well, I took a psychology course when I was a freshman. I was a chemistry student when I graduated. So there are all kinds of things that I never studied. But at the risk of hurting the feelings of people in psychology, they might talk about, they also talk about tastes and preferences the way economists do, but in a little slightly different way. And so they might talk about tastes and preferences driving choice. And they would state things in the sense of partial correlations rather than conditional meaning.